Behind the roar of a wide-body aircraft streaking across the sky lies incredible technology operating with near-perfect precision. At the heart of this magic is the state-of-the-art turbofan engine. Inside the aircraft assembly line, every bolt, turbine blade, and engine module is assembled through a process that combines advanced technology, human expertise, and incredibly stringent safety standards. The assembly process begins with the core engine module. Aircraft engines use a modular approach, meaning the engine is constructed from several large parts that are assembled separately before being combined into a complete unit. These modules include the fan section, intermediate compressor, high pressure, compressor, turbine section, and exhaust system. In the initial stage, technicians install the main shaft, the backbone of the engine. This shaft must be perfectly straight and balanced because it rotates at extremely high speeds during engine operation. After that, the compressor blades are individually installed using high-precision tools. These blades are made of titanium or heat-resistant nickel alloy. One of the most exciting parts is the installation of the front fan, or fan blades. The engine's fan blades are renowned for their enormous size yet lightweight. Each blade is designed to withstand impacts from foreign objects such as birds, without sustaining fatal damage. Fan blade installation is carried out with great care. Robots and hydraulic tools are used to allow technicians to move large components without risk of error. Once all the blades are installed, a computer system checks the rotor's balance. If even the slightest imbalance is detected, technicians must readjust. The next stage is installation of the combustion chamber. This is where fuel and air mix and then burn to produce thrust. Temperatures in this area can exceed 1,700 degrees Celsius, hotter than volcanic lava. Therefore, the materials used must be exceptionally heat-resistant. This engine uses internal cooling technology for the turbine blades. Microscopic holes are created using lasers to allow cool air to flow across the blade's surface. This technology allows the turbine to operate in extreme temperatures without melting. During the assembly process, each cooling channel is inspected using a special camera to ensure there are no manufacturing defects. Besides strength and efficiency, safety is a key factor in aircraft engine assembly. Every work step is documented in detail. Technicians must record bolt torques, component serial numbers, and the ambient temperature during installation. All data is stored in a digital system and can be traced even decades later. A modern turbofan engine consists of tens of thousands of components. An aircraft engine, for example, has a fan blade diameter of over 3 meters and is capable of producing over 97,000 pounds of thrust. To produce such power, every component must operate within extremely small tolerances. Even a deviation of just a few microns can impact fuel efficiency and flight safety.